My name is Matt Bauhoff. I'm a professor and department chair here in the Hildebrand Department of Petroleum and Geosystems Engineering. My associate chair, Dr. Pradanovich, is here, but I think she's going to have to step out after a few moments. And we do have another couple professors who are going to later present a little bit about their research, and that's Dr. Mohanty and Dr. Hadari. So with that, I'll get started. I have several slides. I would say that if you have questions, maybe either hold on to them until the end or post them into the chat. I may answer your questions as I go through the slides. But there'll be plenty of time for questions and answers at the end of the presentation. So a little bit of the agenda. I will a little bit talk about the University of Texas at Austin, the Cockrell School of Engineering, and specifically the Hildebrand Department of Petroleum and Geosystems Engineering. I will turn it over for a period of time to two of our faculty, Doctors Mohanty and Hadari, who are going to talk about their research, and they may be looking to pick up new graduate students in the fall of 2025. Then I'll talk a little bit about the requirements for an MS and a PhD program. So we are recording this session so that we can post it online for anyone else to see. So a little bit about the University of Texas at Austin. It was established in 1883. It is one of the largest universities in the United States, about 51,000 students, undergrad and grad. You can visit our website to learn more. We are in the great city of Austin, Texas, and you can see that our logo is the Longhorn. So at the University of Texas at Austin, we have amazing academics and athletics. So our football program is very popular. We are ranked number 2 in football. We look to be poised to make the playoffs in a couple weeks, but we have other outstanding athletic programs, including swimming, track and field, volleyball, men's and women's basketball, and we are and you will hear me say this probably several times, we are the #1 petroleum engineering graduate program in the United States and in the world. So if you're interested in solving the world's energy problems, we are the place to go for that. A little bit more about Austin and Central Texas. So we are known for our barbecue. So we've got some of the world's best barbecue, breakfast tacos. Our Tex-Mex restaurants and our margaritas are very popular. Lots of pretty sights and outdoorsy things to do here in Austin, Texas. The flowers are very pretty in April. You can see Barton Springs Pool, the Natural Bridge Caverns, Enchanted Rock. Lots of things to do inside the city of Austin, but also lots of things to do with a short distance outside of the city. So really a wonderful location. It's one of the most popular cities in the United States. So the Cockrell School of Engineering is regularly ranked in the top 10 of engineering universities in the United States. We were #8 recently in 2024, and you can see all of our programs and how they're ranked at the University of Texas. And of course, once again, I'll point out that we are the #1 ranked petroleum engineering program in the United States by U.S. News and World Reports, as well as in the world by the QS rankings. So we have in all 7 engineering departments, about 6,000 undergraduates and 2,300 graduate students. A little bit about our department at a glance. We have about 400 undergraduates and 150 graduate students. About 2/3 of those graduate students are PhD students. The remainder are master students. We have 23 tenured or tenure track faculty, 16 SPE distinguished members. I don't think that there's a department in the world that has nearly that many. if I'm not mistaken, and we have 5 members of the National Academy of Engineers. So having just one faculty who's a member of the NAE is phenomenal, and we have 5. We bring in about $20 million in research funding per year. That money is largely spent on you, the graduate students, to support your work, whether that be through stipends or tuition or or laboratory materials, travel, and we'll talk a little bit more about that later. So we have a bachelor's in petroleum and geosystems engineering. We have a sustainability energy minor. We have master's and PhD programs in petroleum engineering, and we're creating a new master's program right now with a tentative name of Earth Energy Engineering. That hasn't get started yet, but for those of you that might be coming for a master's degree, if you're interested in that, you might be able to switch over when that goes live, which we expect to be within the next year. Well, I'll just keep on talking about our amazing rankings. We are ranked at the undergraduate level 1 or 2 pretty much continuously for as long as they've been doing the undergraduate rankings. Our graduate program has been ranked #1 for over 20 years. And so that's based on US News and World Report. And for 2 years in a row, we've been ranked #1 in the world by the QS rankings, and we're the only U.S. university to be ranked #1 in those rankings in petroleum engineering. A little bit more about our faculty. So if you are currently a petroleum engineering or similar program student, you might recognize some of these names and faces. You probably read papers or you've had textbooks in your classes based on them. Again, 16 distinguished members of the Society of Petroleum Engineers, 5 members of the National Academy of Engineers, 3 Texas Ex's Teachers of the Year, and we've had a couple of faculty who won NSF Career Awards. So I will just show this slide and then I'll turn it over to a couple of our faculty. So this is kind of a breakdown of the research we do. I'll focus mostly on the subsurface applications. You see we do a wide variety of research. And so probably 50% or maybe even less than 50% is oil and gas. So conventional or unconventional oil and gas. We do offer degrees in petroleum engineering, but we're so much more than that. We are anything involving the subsurface or even things that extract from the subsurface. We talk about emissions is the type of research that we do. And one of the things I like to say is that there is no energy future without the subsurface. And so whether we're talking about conventional or unconventional oil and gas, geothermal energy, CCUS, hydrogen, lithium extraction from brine, or even nuclear waste storage, that's a subsurface problem. And that's what we work on in the department. So if you're interested in energy, we're the place to be. In terms of technical disciplines, you can see that we're a wide range of technical disciplines, and we also use a wide range of engineering tools, whether they be experiments or modeling, small scale or large scale. But with that, I think I will turn it over to a couple of my faculty, and I'll start with Dr. Mohanty, who will talk a little bit about his research.
All right. I hope you can see my slides. As Matt was telling us, we do the energy for the subsurface. So we have a Center for Subsurface Energy and Environment, where our work sort of intersects between the earth, the environment, and the energy. As you know, the demand for energy is growing because the population is growing. And currently, about 60% of the energy comes from oil and gas. But burning of oil and gas does produce CO2, which has environmental effects. So we got to minimize that. We got to minimize the greenhouse emissions. So in the US Department of Energy, this is a chart from them, and they're thinking of a future where you get your electricity from renewables, nuclear, and fossil fuels, but you try to capture the CO2, that's called the CCUS, carbon capture and utilization and storage. You capture the CO2 the burning process creates, and you try to store that in underground. And also, you take the fossil fuel and convert that to hydrogen. So, such as if you have methane, you can convert that to hydrogen and capture the CO2. So, if you can do that, then you will have, you can meet your energy, and you can also minimize greenhouse gas emission. And so, a lot of the fuels will be converted to hydrogen, and there will be a hydrogen economy. So hydrogen can be used for chemicals, for heating, for metals production, and so on. And this hydrogen, if we use in that large scale, we have to store it. And that the large storages can only come from subsurface. So we have to also worry about storing hydrogen in caverns and permeable media underground. So this is the future we are going towards. So in our research, now I'm going to talk about my research. Right? So in my research, here are some of the topics, and I'll describe them a little bit. So we are doing some work on carbon capture and storage. So we study injection of CO2 into aquifers and depleted oil and gas reservoirs, and how to store them, how do they transport when you inject them. So we study viscous fingering of CO2 inside reservoirs and how we can mitigate them through foams or WAG processes. We also try to convert CO2 gas into minerals. So mineralization, we make some minerals by reacting CO2 with certain things underground and above ground as well. So one of my students is looking at mineralization of CO2. We also work on hydrogen generation and storage. So in terms of storage, if we put the hydrogen into the underground reservoirs or caves, we have to worry about what kind of interaction it will have with minerals that's already present there, or microbes that may be present there. So we are studying reaction of hydrogen with our subsurface minerals as well as microbes that may be present there. We are also starting to look at how we can generate hydrogen from different subsurface components, such as minerals, as well as hydrocarbons that we may have. We also work on enhanced oil recovery, especially from unconventional rocks such as oil shales. So as you can see in this chart at the bottom, we can inject CO2 or other hydrocarbon gases into our fractured wells, and these gases can go in and mix with the oil there, and we soak it for some time, then when we produce back, it can bring back some oil with it. So we have been trying to study these processes at high pressure and reservoir temperatures, and try to understand the mechanisms and how we can optimize these processes. We also work on a phenomenon called wettability alteration. A lot of the carbonate reservoirs tend to be oil wet. So because it's oil wet, oil sort of sticks to it, and when you do water flood, your recoveries are not very high. So it would be prudent to change the wettability to more water wet conditions. So we have come up with some chemicals that can do that. In fact, we just ran a 5-year project with Department of Energy, doing that in a field and demonstrating that it can be done if you do it the right way. The other big project we have is chemical flooding of high temperature, high salinity reservoirs, carbonate reservoirs. So these are some reservoirs where you can inject surfactants and polymers and nanoparticles and try to mobilize the oil. But we got to make sure that at the high temperature, high salinity conditions, they're compatible with the brine that's there. So we systematically synthesize some surfactants and nanoparticles, and we study their phase behavior and transports, and we try to optimize this set of processes. So if you come and join my group, you'll learn about surfactants, nanoparticles, and polymers. We'll make foams, micromodules, and gels. You'll learn about how to model them through simulators such as UTChem. You will also use a lot of facilities that the university and our department has, such as X-ray CT, NMR, IFT, interfacial tension determination, core floods, gas chromatography, high pressure liquid chromatography, and such analytical stuff. So to do all this research, we need students, right? And we also need funding. We have some funding. And so you guys are the students. This is my group right now. And we have about 14 people in our group, about 11 PhD students, and some postdocs and research scientists. So with that, I'll conclude. If you have any questions, I can take it right now.
I'd love to ask, what exactly are you looking for in a student for PhD? What exactly are the qualifications or research? Like, if a student is interested in aligning with your research group, what exactly are you looking at for in that student that makes you accept?
Okay, your question is what qualities am I looking for my students, right?
Yes,
let me answer.
That's the question.
Okay, yeah. So I'm looking for students who are curious and hardworking and have a good petroleum engineering background or some chemical background. And I think that's all I need to have a good PhD student.
But to follow up on that, I am going to talk a little bit about our admissions process in a few minutes. So there's an admissions committee that admits students, and then from those admitted students, faculty may choose to add students to their group, which are a good fit. But I will cover that more later.
During chemical ER, do you deal with viscoelastic polymers or you usually deal with just normal polymers?
So in a typical surfactant polymer flooding, you may not need the viscoelasticity. But if you are doing just a pure polymer flooding, the viscoelasticity helps a lot, and you can reduce the residual oil saturation significantly. As Dr. Balab's, he has a few papers on it, and its viscoelasticity is very desirable for polymer flooding. Yes.
Yes. So also in carbonates, you work in high temperature and high pressure reservoirs, as I saw on your slide.
Yes.
Okay. What about sandstones? Are you currently working with sandstones?
Yeah, we do work on sandstones too. We have a few cases where we're working on their high temperature of the order of 100 degrees Celsius. And yes, and salinities are high also. But sandstones are a little bit different than carbonates, as you know. So you have to figure out, tune your chemicals to the right environment.
Okay, how about we turn it over to Dr. Hadari?
Thank you, Matt. So let me share my slides very quickly. So I'm Zoya Haydari. I'm a professor at the Hildebrand Department of Petroleum and Geosystems Engineering. And I'm leading a team working on multi-scale rock physics. And I'm going to talk a little bit about what we do in my research group. And I hope I can answer the questions that you have today. So I have had the pleasure of working with very, very many stellar students during my academic career, and let me tell you a little bit about my academic career. So I'm a Longhorn, which means that I got my PhD from the University of Texas at Austin, from the same department, Petroleum and Geosystems Engineering, a long time ago. And then after receiving my PhD, I decided to pursue an academic career. So I joined Texas A&M University as an assistant professor at that time. And 4 years later, I decided to come back to UT Austin. So UT Austin gave me an offer and I came back here as a faculty member. And since then, I have been a faculty at the Hildebrand Department of Petroleum and Geosystems Engineering Department. And I have had the pleasure of working with many great students and researchers at UT Austin. So, and I always have actually open positions in my research group, and I look forward to working with new Longhorns who decide to join UT Austin. So let me tell you a little bit about my research at the University of Texas at Austin. My main field of expertise is formation evaluation, rock physics, and petrophysics. And let me tell you a little bit about what it means. So in my research group, we develop new techniques to characterize subsurface rocks, to understand the quality of them, the type of fluids we have, and how easy those fluids move through porous media in the subsurface. How do we do that? Well, we develop new techniques. Either actually we take samples from the subsurface, bring them to the lab, analyze those samples, or we send tools to the subsurface and we analyze the measurements we collect from those tools, or we collect measurements while we takes measurements from the surface and analyze those measurements to figure out how the rocks look like. For what applications? So we cover a wide range of applications. It can be for hydrocarbon production, or it can be for characterization of subsurface aquifers to produce the drinking water, or it can be actually for any sort of storage related problem, because we can store gases, including CO2 and hydrogen in the subsurface, or other type of storage in the subsurface. For all of these, we need to understand how the rocks look like, and this is what we do in my research group. So a little bit more about my research group. So we work with multi-scale and multi-physics formation data that we collect either on the subsurface or on the surface or on the samples we take from the subsurface or from the surface from the rocks in the lab. So we develop rock physics models and experimental methods for enhanced formation evaluation. We already talked about what formation evaluation is. Some unique characteristics of the techniques we develop in my team is we quantitatively take into account geochemistry and multi-scale quantitative rock fabric into evaluation of the data that we collect to understand the rocks. And the outcome would be enhanced petrophysical evaluation, compositional, interfacial, mechanical, and geochemical evaluation of these rocks for the purpose of designing completions and storage decisions as well. We also actually work on lots of projects related to CCUS, hydrogen storage, and also geothermal applications. So in my research group, we do believe that we need unconventional rock physics models and measurement techniques for evaluation of formations with complex rock physics. And this is what my students and researchers do in my team. And we also believe in the value of integration of multi-scale formation data in understanding subsurface rocks. Now, let me actually go through some of the highlights of the program I'm leading at UT Austin. So we integrate experimental and computational rock physics and petrophysics. Examples of the projects we have in this category is developing analytical and numerical models for rocks with complex rock physics. Examples related to our analytical and numerical modeling include the development of new techniques for quantifying solid fluid interfacial interactions, including wettability, for instance, or techniques that we have developed for real-time assessment of capillary pressure and pore throat size distribution. We also actually developed new experimental methods. A good examples of this category includes the projects, for instance, that we have active on developing new experimental techniques for assessment of dynamic petrophysical properties on irregular shape tight samples. That brings lots of value, information evaluation of rocks. And another category includes fundamental research in rock physics. Good examples in that category is the methods we develop for understanding how, for instance, CO2 and hydrogen reacts with different rock components in the presence of subsurface fluids. And how we can actually make the environment or select an environment that is beneficial for the purpose of the storage of these gases in the subsurface. We also integrate multi-scale formation data. We work both on computational research and experimental research. My students typically work on a combination of computational and experimental research, but I have some students who only work on computational related research and some students who only work on experimental research. But we believe in the value of integration of these two categories. Another point that I would like to mention in here is the multidisciplinary nature of the research that we have in my research group. So I have students from a variety of disciplines. I have students from physics, discipline geology, students with expertise in data science, mechanical engineering, civil engineering, chemistry, geophysics background. And this is all because of the multidisciplinary research nature of the research we have in our research group. And we have lots of collaborations with people with different backgrounds. Examples of those is, for instance, understanding how molecular bonds actually changes in organic content, in organic rich mud rocks when it is in contact with water, right? And it is very important for production decisions and the strategies in unconventional reservoirs. Another example includes actually image analysis, for instance, to perform rock classification or to extract rock fabric from different sources of images, including borehole images or CT scan images or core photos. Another example would be actually the type of molecular scale modeling that we do to understand the role of or the impact of molecular structure of different components that we have in subsurface rocks. So these all require a multidisciplinary environment, and I encourage this kind of environment in my team. So one last point that I would like to mention about this program is the goal of everything that we do, either fundamental research that we work on or the applied research that we work on, computational or experimental, is to develop new techniques that can be used by the energy industry. Examples would be enhanced decisions for completion related petrophysics, or geophysical monitoring, aquifer characterization, carbon sequestration, and hydrogen storage informations with challenging rock physics. And the research that we do have had impacts on all of these categories. I'm very proud, as I mentioned, of each and every one of the students and researchers that I have worked with. They have published several journal and conference papers. They have been recognized as distinguished presenters for the work that they have done. For instance, in the case of distinguished speakers or presenters of SPWLA, my team members, students have been recognized 12 times in the past as distinguished speakers of SPWLA, for instance. They have received numerous international technical awards from multiple societies, including SPE, SPWA, EAGE, AIME. Something that I'm very proud of them for is that they are developing some research outcomes that are being used by our industry collaborators, and we all have been successfully collaborated within the energy industry during the past years. So I'm very proud of my team, and I hope we can have fabulous team players added to our team, and I can have the opportunity of working with some of you in the future. So we have a research website called Ultra Petrophysics website, and well, the link is here, so you're more than welcome to visit the website. We have some information about the vision of our research, the projects, some of the projects that we are working on, some previous publications, achievements of the team, and so if you have any questions, please feel free to email me. My information is listed over there as well, and it's also listed on our department webpage. So I will be more than happy to talk with you about your research interests and the possibility of joining my team if you're interested. So thank you very much for attending this meeting today, and let me know if you have any questions.
First of all, thank you for your nice presentation. And I would like to ask you that, as you mentioned from your research, do you use or do you utilize from the micro CT images in your
Yes.
research?
Well, thank you for your question. Yes, so as I mentioned, actually we use data that is collected in multiple scales, and macro CT images are actually a good source of information for us, a good source of data for us. And yes, we do work with micro CT scan images as well, depending on the type of rock that we are working on.
I have a question related to natural fracture formation. How can I identify the fracture density, fracture orientation from this kind of formation?
Okay, so and thank you for the question. So yes, one of the projects that we have been working on for on and off for many years have been actually characterizing fractured rocks. So when we have worked on different techniques for characterization of fractured rocks, well, obviously one of the techniques is image analysis, working on images of different scale taken at different scale to characterize fractures. Another actually work that we have developed related to fractured rocks was through injection of contrast agents and use of contrast agents. And by contrast agents that I'm talking about, it were magnetic nanoparticles, and use that concept for fracture characterization using different geophysical measurements, including electromagnetic measurements as well as NMR measurements.
I have an inquiry. Are you interested in working in organic rich shales and how to generate or accelerate the generation of hydrocarbons from these resources?
Well, a big portion of the research projects that we are working on in my research group are related to organic rich mud rocks or organic shales, as you mentioned. We are working on different aspects of production and basically rock characterization in organic rich mud rocks. So about maybe 50% of our projects or more are related to organic rich mud rocks. It changes in time, but a big portion of my projects are related to these kind of rocks.
Okay, well, I'm going to continue my presentation. So I think you should be able to see this. So we were talking a little bit about the research that's done in the department. Dr. Mohanty and Dr. Hadari gave examples of their work, but again, we have 23 faculty that work in a very wide range of research. And so if you were admitted to the department, you might contact the faculty that are doing research that most interest you. A little bit more, some other examples. So Dr. Van Oort, for example, his lab does drilling type of work, and so they've got consortiums on that. You already heard from Dr. Hardari in her lab. We're doing amazing work in the area of AI and machine learning. There's really no petroleum engineering department, or really, I'd put us up against any engineering department in the world, what we're doing in machine learning, AI, and data analytics. That's led by Dr. Perch, Dr. Foster, Dr. Tang, but really all of our faculty are doing things in that area. Other work that's being done, Dr. DiCarlo, and he's working on decreasing methane emissions. Dr. Daigle is working on reducing the amount of water being produced, and how to deal with that water during oil and gas operations. Dr. Sharma is making pipelines safer for the public environment through fiber optic cables. Dr. Ravi Kumar is doing emissions modeling. Dr. Song is doing rare earth metals recovery. So again, anything that involves energy in the subsurface, we're working in that area. So if you're interested in learning more about what we're doing, there's lots of different opportunities for that. You can visit our webpage, and we also have a YouTube page, so you can see where that is over there. Our LinkedIn page, you can see that Dr. Bernanovich and I post lots of things. Maybe that's why you're here today, is because you saw what we had on there. Our research center, the Center for Subsurface Energy and the Environment, has lots of information on the research that we're doing. And there's also live webinars once a month, and we record those on YouTube. So you can watch various presentations by all of our faculty on things that they're doing. So like a 45-minute technical webinar if you're interested. And what about grad student life? So first year students, you can join a PGE Energy Net Mentoring Group to learn from more senior graduate students just about how to be successful, what it's like to be a graduate student, maybe even advice on the university and the city of Austin and how to be social. We strongly encourage you to join our many organizations, including the Society of Petroleum Engineers, Petroleum Graduate Student Organization, American Association of Drilling Engineers, Society of Petroleum Well Log Analysis, and the Women for Petroleum Engineering. There's also the School of Engineering. You can learn about more broader organizations, or even things on campus. So things that don't have anything to do with engineering. If you're excited about doing just things that are your hobbies, right? There's a student org for almost everything. And again, we're one of the largest universities in the United States, so if you have an interest, there's probably a student org and a group of people that share those interests. And then you can follow us through our various social media accounts. I mentioned LinkedIn, but also Instagram and Facebook and other things. We do have lots of competitions. So here's our Petrobol team that is competitive almost every year. We're very active in the Society of Petroleum Engineers paper contest and other paper contests, like through SPWLA. We just competed in the global switch competition, and our team came in second place. So lots of opportunities to get involved there as well. Okay, so how do you apply? So first off, you can go to our website, and there's an admissions page, but you can go to this link or and learn about our master's and PhD in petroleum engineering. It looks like our master's degree in earth energy engineering won't start until fall 2026. However, I believe that if you were to choose a master's in petroleum engineering, you could transfer over to our triple E degree in 2026 when that launched. The master's and PhD application deadlines, if you're looking to start fall of 2025, then it's going to be December 15th. So that's 2 weeks from today. You'll need to submit your application, but it's September 1st for the spring semester. And then what you're going to need is an application form and fee, your official college transcripts, your resume. You'll need to write a statement of purpose, why you want to go to graduate school, or particularly in PGE. You'll need 3 recommendation letters. These can be from professors that you've worked with, or maybe if you've done some undergraduate research, the professor you did research there, or if you had an internship with a company, those recommendations. You do need to take the GRE, and we do not waive the test. So don't bother asking me that question, because we do not waive the test. It is required for everybody. We've made a decision to make it a requirement, and we want it to be equal for everyone. If you haven't taken it yet, take it as soon as you can, and we'll accept late GREs after December 15th. But really, mid-January is the latest we accept that, because we can't admit anyone without reviewing their GRE. And then also the TOEFL or IELTS is required for English proficiency if you're an international student. So if you're a domestic student or you've gotten a degree in the United States, I don't believe you have to take that, but international students do. I do want to point out that we have a holistic process. So no one of these things is, will necessarily make the difference. So, the GRE, for example, is required, but if everything else looks strong and you didn't do as well as on the GRE, then that may be okay. So don't overthink anything, but we do need all of these things for the application process. I'm gonna just kind of gloss over this quickly because it's not going to be implemented in 2025. It will be in 2026. But we're working on a new Masters of Science Engineering. This would focus on subsurface applications outside of oil and gas. So, geothermal energy, hydrogen storage, carbon capture and storage, and methane emissions abatement, those kinds of things. Although I will point out that if you get a petroleum engineering degree, you can still take these classes and you can still do research in that area. But if you are interested in this degree, I would recommend you apply for the Master's in Petroleum Engineering, and presuming that it's effective in August of 2026, if you're still interested, you should be able to transfer it over. So one thing that there's lots of questions about is funding and support. Before I explain this, I will say this, is that the process is to first apply, and the admissions committee will review your case, and the students that are deemed admitted will then be shared with faculty who will either reach out to you, or then you can reach out to them about funded projects. This may be a little different than other universities. Many of you will email faculty now and ask for funding for a project. You will usually not get very positive responses there, because that's just not how we do things. Even if I wanted to fund you in a project, I can't until the admissions committee admits you. So that's why you have to apply first, and then from those students that are deemed admittable, then you will be then you can get connected with a faculty member. But I will say that 70% of our students are supported by research grants through the department, and it's probably even higher than that for PhD students. So you will either be a graduate research assistant or a teaching assistant, or more likely a mixture of both. So if you were to work in my group, you would be a GRA most semesters, but you'll almost certainly be a TA at least one semester. The salaries right now are $34,000 per year for a GRA or TA. That's for 12 months, plus benefits, plus tuition. So we pay for your tuition. That's approximately $13,000 in state. On top of that, for PhD students, we do have, and I've got this at the, we do have some topper fellowships of $6,000 per year. That's for PhD students. For master's students, some students may also get some sort of topper fellowship, but you're guaranteed the $34,000 as a GRA or TA. I will also point out that many of our students will get internships over the summer. Maybe not every summer, but many of our students do, and those tend to be relatively lucrative if you work for a company. Some of our students are supported by our foreign government or individual companies instead of receiving a GRA or TA in our department. And then there are various fellowships that you can apply for individually. For example, the Fulbright Scholar or the U.S. Department of Energy. Some of our students are self-supported. And again, there are some topper scholarships on top of the stipends. So again, most of our students are supported, even master students, but certainly our PhD students. But the process is always to formally apply first, and then students that are reviewed and reach the level of admission, then faculty may contact you, or you may contact faculty, for a project that you are interested in. Some of the degree requirements. For a master's degree, there is a thesis option, which is 24 credit hours, which is really 8 classes plus a thesis. You can do a report, which is 30 credit hours or 10 classes plus a report. There is a PhD fast track. So let's say you have an undergraduate degree but no master's yet, and you're certain you want a PhD, then you can do the 30 credit hours plus a report. And then go directly into a PhD. So that might be a little bit faster way to do that. And then I don't recommend this option, but it works for some people, is a no thesis, no report, which means you basically just take 12 classes and you get a master's degree and they go out. So that would mean no research with a faculty member. You almost certainly wouldn't have a GRA. You may get a TA. But in my opinion, the reason you go to graduate school is to do fundamental research that's going to change the world. And so that's why, there are some exceptions, but that's why I usually don't recommend a no thesis, no report. But the thesis option might be a way to get that. So the requirements, so if you're a petroleum engineering undergraduate, that's fine. An engineering area, so you don't have to be a petroleum, you could be a chemical engineer, a mechanical engineer, or really other STEM field. So if you're in geology or physics or chemistry, then that and you're interested in that may be sufficient. You need some additional writing if your GRE verbal is less than 153. But there are opportunities to address the writing issue if your GRE is less than that. The course requirements. So for the thesis option, you need 24 credit hours, as I mentioned, 30 for a report option, and we have different modules that you choose from, and I'll get into that. So if you, and I already kind of discussed some of this, so I won't get too much into the details here for now, but I will say, so module 1, includes classes like engineering analysis, which is basically mathematics, advanced petrophysics, transport phenomena, you may have called it fluid dynamics or something, or advanced thermodynamics. So you may choose 3 of these classes. For example, then module 2 would be more specific to petroleum engineering, things like reservoir engineering or well logging or drilling or production engineering. Then there's various electives, and we have lots of electives in the department. And then you could take module 4 classes, which would be outside electives. So things in, say, a different engineering, or maybe even the Jackson School of Geology. For the PhD degree track, if you've already got a master's, or if you first earn a master's in our department, then you would need 24 additional student credit hours beyond the MS degree. So that would be like 8 classes. At least 15 semester credit hours must be PGE courses. So that would actually be 5 courses. And if you already have an MS in petroleum engineering from a US or Canadian, then that decreases from 24 to 18 semester credit hours. So you'd only need 6 total classes after your master's to get a PhD. Really, if you're a PhD student, most of your time is not going to be in the classroom. It's not going to be studying for tests. It's going to be doing, fun, fundamental research. And then I did mention that there are options for a bachelor's degree to a direct PhD, so you wouldn't get a master's at all. I would say that this option works for some students, but I think that if that's something that you're interested in, I would have a discussion with us once you come here to see if that works best for you. Because I think for most students, this is my personal opinion, but for most students, there's a lot of advantages to getting a master's degree first. There are some exceptions, but most of the time, I think getting a master's first, kind of getting your feet wet and taking some classes and understanding the culture of the department and the university before jumping into the rigorous PhD program is often advisable. If you do come to get a PhD in petroleum engineering, and we do want our students to get PhDs, even if you come here for a master's, we almost always like for you to stick around and get a PhD. The fun thing about being a PhD is that you are literally the world's expert in a subject. So what are there, something like 7 billion people in the world today? At the end of your PhD, you will know more about that subject than any of the 7 billion people in the world. And that's really cool. To do that, you'll have to pass a qualifying exam. You'll have to choose a research topic, work with a faculty advisor. You'll have to complete some academic programs, so coursework, get a minimum GPA of a 3.5. You'll take an oral proposal exam. That will be, you'll write a proposal and then you'll give a 30-minute presentation about what you propose to do for the next couple of years. You'll enter candidacy. At the end of candidacy, you'll give a final presentation summarizing your research, and then you go into graduation, and then finally, you'll hopefully be placed in a job. And I will say that the vast majority of our graduate students, especially PhD, get outstanding job placement in our department. And again, with our reputation as being the #1 department in the world, lots of companies are coming to hire us. So you can learn more about the degree requirements on our website. And I've got a picture there. So if you go to our PGE website, if you go to our graduate program, you can see over here, you can learn about admissions, so how to apply, tuition and funding, degree requirements, careers, student organizations, and then a lot of your questions might be answered under the frequently asked questions. And I'd also like to point out Amy Stewart. So she's the graduate coordinator. She would actually be much better at answering the logistical questions that you have than I probably do. So with that, I will open it up to any questions you may have. You can either ask them out loud or you can post them in the chat. So whatever's more convenient for you.
Hi, Professor. Thank you for the information that you've already shared. And I would like to ask you that, is it possible to transfer credits from another university for the master degree?
Oh, I want to say no. I don't know if Dr. Perdanovich is there, if she can answer that.
I can jump in. So this is something that is evaluated by the graduate advisor. But for the most part, we actually do require our own paper, our own coursework, especially on the graduate level.
The chat asks, I would like to be clear in the PhD fast track program. I just completed my bachelor's and I'm confused to pursue a master's or PhD directly. So I'll probably pull up my slides again since I went through that quickly, but so you can either go directly to a master's, complete a master's, then get a PhD. And my personal recommendation, and this is my recommendation, is for most students, that's probably the best option. However, we do have students that have successfully gone directly to a PhD program. And let me pull up my slides to summarize that process.
As you're pulling them up, one practical difference between the two is that the moment you enter a PhD program, you need to take a PhD qualifying exam first time it's available.
Yeah, and so that's one of many reasons why I don't usually advise it. The qualifying exam is rigorous. It might be asking a lot for many students, especially those that are international, that are in a brand new country, in a brand new campus, and trying to get situated and trying to learn about graduate school to immediately take such a rigorous program. But it works for some students. So the PhD fast track option requires 30 credit hours. So that'd be 10 courses. And you can see that, some of those are from module 1, 2, and 3. You would write a report, but you wouldn't write a thesis. And you would, okay, I'm sorry, Masha, the fast track is a little different from the direct to PhD. Is that right?
No, well, this direct to PhD, I think, is for our own bachelor students, and you do not receive a master's degree. So there are two options.
Okay, so
Yeah.
but this would be
but basically direct to PhD is more coursework. So the more coursework you have, then on the way to master's. So there are multiple ways to do master's. I think that's important to recognize. You can simply skip it, in which case you can't skip the coursework, or you can do some master's research. And if it's larger level research, then it's a master's thesis with the appropriate number of credit hours that you register as you're doing that research. And if it's master's report, it's a little bit less in the scale. So master's report, less work, master's thesis, more work. How's that? In terms of research work. And then you can also simply have a course option for master's, which is 36 hours. So that's this no thesis, no report option. And that's what the previous slide is referring to. So if you skip any type of research work for master's, then you need to do 36 credit hours of coursework.
And I'll say a couple of other things. First off, if you're a bachelor's, if you have an undergraduate degree but no master's yet, but you know that you're interested in a PhD eventually, then definitely indicate that on your application. And then the second thing I would say is that whether you choose a fast track to PhD option, we may be able to figure that out once you arrive to campus. And so
correct.
I think that that's something that, maybe you get admitted, you're like, look, I know I want a PhD eventually. I don't know what's best for me. That might be something that would be best to have a discussion with in person with myself or other faculty or even some other graduate students. And
so the moment you come in, you will also be advised by a graduate advisor that is Professor Sepernori, as well as Ms. Amy Stewart. So together at that time, when you actually come in, you can decide which particular of these options you would like, especially after you hear all of these options once again when you're admitted. So I wouldn't, as Dr. Bauhoff puts it, I wouldn't worry about it too much right now, but do make sure that if you are ultimately interested in PhD, to indicate that on your application. It will ask you whether you're ultimately interested in PhD, to which you should say yes if you are.
I would like to know if there are chances to have a GRE waiver for somebody with an undergraduate degree in petroleum without a master's, but has about 6 years experience in the oil and gas industry. I don't know if that passes for anything.
There are no GRE waivers. Now, again, all of these other things, like you mentioned, your experience will be taken into effect. So maybe if you didn't get the GRE score that you'd hoped for, maybe we don't take that into account much because you've got experience and you've got lots of other great qualifications. But to be fair to all students, we require it for everyone. If you haven't taken it yet, and you can't take it by December 15th, then just take it as soon as possible and submit your GRE scores, I would say by mid-January at the latest. But no waivers, but it's not the end all be all. We try to look at everything holistically.
Just to underline those words a little bit, the moment we are requesting GREs, you have to have GRE on record for graduate school to process your paperwork. And that's above us. There is no email or letter that Dr. Balhoff or I can write to waive GREs. If we are waiving them, we have to waive them for everyone. And if you're asking for them, we have to ask them of everyone. Otherwise, there's no way we can issue you, for instance, a letter to admit you to the program. We cannot admit you to the program formally until you have GREs on your file.
Got someone in the chat. So it says, I would like to inquire if there are any opportunities for international applicants to have the application fee waived. So again, there are no waivers for applications either. That is not an option. Just to be fair to all the students, the application fee is unfortunately required. I could, we should point out some minimum requirements for admissions and some average requirements for admissions. To get into the PhD program, the minimum GPA is a 3.5. Some international universities use a different scale and there's a conversion process, but it's a 3.5 out of 4. The minimum for master's is a 3.0. Those are the minimums. That doesn't mean that you'll be admitted with those scores, but those are the minimums. I would say that the averages are probably a little higher than both of those. And then for a GRE score, again, this is just an average and we use a holistic process. So, but I would say that the average GRE score is a total math plus verbal around 320. So usually maybe math a little higher than 160. We are engineers after all. And then for the verbal, maybe the average is a little less than 160. But again, we take things into account, right? So if you're an international student and you've got an impeccable resume, but you just didn't do well on the verbal, we often overlook that. I've got another question. How long does it take for the committee to make a final decision on the student admissions and get back to the applicants? Usually late February. Mid to late February is when we let you know whether about admissions. And then at that point, faculty may start to reach out to you because faculty have been given a list of admitted students, or you can reach out to faculty and let them know is that I've been, I've learned that I've been admitted. Do you have any research positions open? And then usually by April 15th, all the offers are officially sent out. Another question we have is, I have a question about recommendation letters. Do you have any special phrase you look out for in the letters? So that's the first question. I would say no. I think we're just looking for a strong letter of recommendation. If you can get somebody who knows you more than just somebody who taught you in class, then that's helpful. So don't get a family member or friend. Okay, do not get a family member or friend. That's not helpful. But maybe a professor that knows you really well. Maybe if you did research with them, or you worked with them in a student organization, or maybe if you worked in an internship and your boss could write a letter, but something that just talks about your technical abilities, your work ethic, your enthusiasm. That's what we're looking for there. And then we have another question about waivers. So do you waive English tests for international students with English as official languages? And if Masha's still there, I think the answer is no on that as well.
Yeah, I think those are still needed. And it's not our role, it's Graduate School of UT Austin, which is separate from the department and basically rules the entire university, so we cannot necessarily override it.
And Dr. Pradanovich clarified that February 1st is when the first round of application reviews.
Yes, I was actually just typing in one more clarification. So you will first learn whether the graduate admissions committee has reviewed your application favorably. That does not come with the financial offer. After that, we make those files available to the faculty and they can review and make financial offers. Then those financial offers, majority of them is late February, as Dr. Balhoff pointed out.
Yeah.
So there is a timeline there. So first you will actually just get an email saying you're admitted or not admitted. For all of that, for us to issue any of those decisions, your file has to be complete. So for instance, if we haven't gotten your transcripts from your university, we can't do anything one way or the other. So you have to understand that. And we do often have a lot of hanging files that haven't been submitted. So again, it's not our role, it's graduate school.
I'm going to answer a question that wasn't asked, which is what do we look for in a statement of purpose? The first thing I will say is do not, I repeat, do not have ChatGPT or another AI source write your statement of purpose. That'll be very obvious to us, and that's probably a good way to have it thrown out, or to lose consideration. But one thing we will want to look for, and this is maybe lesser, is just your ability to write a little bit, because a big part of getting a PhD or master's is going to be writing papers and writing theses. But more importantly is just for you to show that you've really thought about graduate school, why you want to go into graduate school, why you want a graduate degree in petroleum engineering, and that you've really thought about your research. Now, you're not tied to the research in there, right? So you could say that, oh, I'm interested in geothermal energy or enhanced oil recovery or unconventional shales, and you might mention some faculty that work in those areas. It'll help if you did a little research about them and say, I'm familiar with such and such professor's work in this area and that interests me. You're in no way tied to working with them or working in that research area, but it helps to show that you've really thought about why you want to come to graduate school and what kind of research you might want to do. So somebody says that, Professor, so I have a GPA less than a 3.5. Does that mean I have absolutely no chance, even if I have a good GRE score and an overall decent profile? I believe the minimum for a PhD is a 3.5. So you cannot be admitted to the program without a 3.5 for the PhD. Now the master's is less. The minimum is a 3.0. And then there's a question, is the IELTS mandatory even for an MS study in English in foreign country like China? Either the TOEFL or the IELTS is mandatory for international students. So you can take one or the other. Again, that's not something that I would, stress out about too much. It's a requirement. It's not necessarily something that will, it's a holistic process and everything else looks strong, but it is a requirement.
And it is one of those graduate school requirements we cannot waive. So it's applied to everyone.
The question is, how are the funding opportunities for master's students compared to those in the PhD program? So that's a good question. PhD students are definitely more likely to get research funding. If we're just being honest, PhD students are going to be here longer. They're going to write more papers per year. They're going to get more research done. So PhD students tend to be in more demand. So if a faculty member has a funded research project, they're probably going to look for a PhD student first. However, if you are a master's student with an intent on getting a PhD and you're a strong student, then that will help you because the faculty member might, see you as an investment that, yes, you're going to get a master's student first, but maybe you'll stick around for a PhD. But master students, even those that's all they're going to plan on do get funded projects. I've had many myself. Um, Part of that funding may come as a TA. You should definitely be open to that. But I would say that there definitely is going to be a preference for PhD students over masters, but both masters and PhD often get funding. So what is the average GRE quantitative section score in the admitted applicants from last admission cycle? I don't have the data offhand. I can tell you that it is probably in the lower to mid 160s. So
Don't
that's
either, but it's posted on the website, not for the very last cycle, but cycle before. It hasn't changed too much.
and that's average, right? So we
Correct.
do have some that are less, and so if you have um, an amazing GPA, you went to a good school, you have great letters of recommendation, then we're like, well, clearly this is a strong student just because they didn't do well on a standardized test that day. That can be something that we put less emphasis on. The question is, and does the analytical writing play a role? Masha, do you want to comment on that?
The main one we are looking at is the GRE verbal. So, but analytical writing, writing is very important for a PhD degree. So yes, if you have a good analytical writing, that definitely enhances your overall application. Do letters from professors weigh more compared to the others? So professors, to a degree, yes, because other professors in other departments know what it takes to be a successful graduate student. So if you have a recommendation from a professor, they can typically tell us that in their recommendation.
I think a mix is good. I mean,
but a good mix, yeah.
Yeah. What I don't like is, somebody that you took a large class with and the professor says, this student took my class and they got an A. Well, we could have seen that from the transcript, but, somebody that really knows you is always a strong, or if you did some sort of research with them or worked with them in a student org or something like that. But having a letter from a boss that you did technical work in an internship, they can say that you have practical knowledge and that you're a hard worker, that goes a long way too. Different institutions have different grading system for GPA. How can I standardize my GPA? I think the university has some sort of formula to do that conversion. I'm guessing that that's not public. Is that right, Masha?
Correct. So they actually will go and they have professional people who translate GPAs from different countries. That said, the only thing you can do is when you will actually be asked on the form what your GPA is, and you basically just enter it on whatever scale it's at. So say that it's a scale up to 10, well, so you enter what it was on the scale up to 10. You can translate it to the scale of 4 if you'd like, but we can do that much math, so we will do the calculation ourselves too.
Says, do the research excellence, outstanding academic achievements, and teaching awards play a role in enhancing the chances of the applicant to be admitted? I would say absolutely. So if you've done research as an undergraduate or a master's student, you've done good research, you have maybe a publication, if you've got experience as a TA or something, then all of that will definitely be included. You can include that in your statement of purpose. Hopefully, that will be reflected in your letters of recommendation, and it certainly will in your resume. And then there's a question, is there an opportunity for environmental engineer in this domain, PhD and MS? So don't entirely understand your question. So we absolutely, if you're saying you're currently an environmental engineer, the answer is absolutely. We accept all engineering, in fact, all STEM degrees. Even though right now our degree programs are petroleum engineering, we do environmental work, right? So we do geothermal energy and CCUS and emissions. So, and then the third thing is that we are working on a new Earth energy engineering degree, which is environmental in nature. That would be a master's degree. So, but if you're an environmental engineer by training, absolutely you should apply, and you can absolutely do research in that area. Question about postdocs. Will there be any announcements for postdocs later? So the postdoc program is not an official admissions process. There's no deadline. Those are run by individual faculty. So occasionally I'll have a project and I'll have a funded position for a postdoc, and I'll be looking for one. You can email individual faculty and ask them if they have any available. I would say that the success rate by doing it that way is pretty low, just because most of the time we don't have postdocs available, but sometimes we do, and then they're officially posted. So if you go through the UT website, and you can see for some postings, many faculty will post on LinkedIn that they're looking for a postdoc, but we don't have an official program for that.
I just posted the link with UT jobs. So postdoc jobs typically have to be announced on official website. So that's when they do show up, that's when they're available officially.
And Masha, this is a good question for you. So somebody asks, the 3.5 cumulative GPA, is that for their undergraduate or their master's, if they're trying to get for a PhD?
We do look at both. So if you have however many degrees you have, we're going to look at them. Now, officially, as far as the imposed minimum by the university, you have to have a 3.5 in your latest degree, which is master's in this case.
I think we'll close up here, but I just want to thank everybody for their time. I will say that I hope you apply. It is really an amazing department, an amazing university. City of Austin's a lot of fun. Even if you don't come to graduate school in our department, I hope that you consider it perhaps somewhere else, because doing fundamental research is really exciting. And my time as a graduate student was the most fun time of my life. Just working on problems, knowing that nobody's ever solved these problems before, is really cool. And it's an opportunity to change the world. So I hope you apply, and I hope you eventually come to UT Austin. But if you go somewhere else, then I consider that a win for humanity as well. So but I appreciate all of your time.
And just a final note that this will show up posted on our UT PGE YouTube. So watch for the recording if you want it.